For the ellipse, is the locus of points that moves such that the sum of its distances from two fixed points, called the foci, is constant. The constant sum is the length of the major axis. So here's the general equation of the ellipse. Usually, the terms of x squared and y squared, their coefficients are not the same. Unlike on a circle, they are the same. For the ellipse, in determining the standard equation, we should refer first on the figure. We have the minor axis 2b right here. There's the location of vertices for the minor axis. For the major axis, or the longer axis of the ellipse, that's 2a. Now, we have foci here. It's the foci. And the distance perpendicular to the focus within the ellipse is also called the latus rectum. The directrix is located outside the ellipse, which is right here. Okay, perpendicular to the major axis of the ellipse. Now, if the ellipse has a center located at the origin, here's your standard equation: x squared over a squared plus y squared over b squared equals to 1. But if the ellipse has an origin and major axis, on the y-axis, here's your standard equation. So usually a has a greater value, so that's why if in this ratio of y squared, a is on the denominator of y squared, where y-axis has longer axis compared to the x-axis. Now, if the center is at any point on the Cartesian plane h and k coordinates, here's your standard equation: x minus h squared. So just put there minus h and minus k from the previous given standard form of equations. Then take the squares of that. It should be equals to 1. The elements of ellipse, the center is at h and k. If it is at the origin, it should be 0, 0. Semi-major axis is equals to a, and the semi-minor axis is equals to b. Location of foci is c. Using Pythagorean theorem, c is equals to the square root of a squared minus b squared. So, c is essential in locating the foci. Okay, it's the distance from the center going to the foci of the ellipse. Length of latus rectum, we have a formula of 2b squared over a. Eccentricity, distance from the focus to ellipse, and distance from ellipse to the directrix. So the formula is c over a should be less than 1. This is the form of checking that your values are correct. Should be less than 1, your eccentricity. The location of directrix d with respect to the center of ellipse, okay, d is equals to a over e. That's the formula, or you can use a squared over c. Example: given the equation of the ellipse x squared over 64 plus y squared over 16 equals to 1, what is the minor and major axis? Determine the eccentricity, determine the length of latus rectum, find the distance between foci, find the distance between the directrices. So that's all. So let's solve now. The first question is determine the major and minor axis. Here in this form of equation on the given, we can easily change that to standard form, since 64 is 8 square and 16 is 4 square. For a and b, a is the one that has greater value on the denominator that is being applied by an exponent 2. So we have 8, and for b, we have 4. Since 8 is on x, okay, it's the denominator of x squared, it means that your major axis is along the x-axis, and b is on the denominator of y squared, which means that's your minor axis along y. So for the major axis, it is equals to 2a. So 2 times 8 equals 216. And for minor axis, 2 times b, or 2b, 2 times 4, that's 8. And that's the distances of your major and minor axis. Second question is to find the eccentricity. Eccentricity is equals to, for number 2, eccentricity is equals to c over a, where c is equals to the square root of a squared minus b squared. C therefore is equals to the square root of 8 squared minus 4 squared. C is equals to the square root of 64 minus 16, or C equals to the square root of 64 minus 16 is 48. Take the square root of 48, that's equivalent for the square root of 3. Okay, or this one, the factors of that is 16 times 3. That's why we have 4 the square root of 3 here. Eccentricity therefore is 4 the square root of 3 over 8. A is 8. So it should be less than 1. Just to verify if we have an ellipse, 0.866. That's your eccentricity. That's correct. Number 3, determine the length of latus rectum. Latus rectum is 2b squared over a. Just the formula. 3. Latus rectum is 2b squared over a. 2 times b. b is 4 squared over a is 8. So 2 times 16 over 8, 32 over 8. Latus rectum is equals to 32 divided by 8 is 4. That's your answer. It's the length for the latus rectum. Number 4. Find the distance between foci. Distance between foci. Okay. Distance between foci is 2c. Okay, that's 2c. So, since we have c, 2 times 4 the square root of 3 is equals to 8 the square root of 3. 8 the square root of 3 and decimal is 13.856. 856 units. That's your distance between foci. Number 5, find the distance between the directrices. Number 5. For the distance between directrices, use the formula. This equals to A over E. A is 8. E is for the square root of 3 over 8, or 0.866. We use that. We have 8 over 0.866 is 9.238 units. distance between the directrices is 2D. Okay, just based on the figure. Okay, because as you can see here on the figure, an ellipse where here is your directrices, so here's your D, so that's why you use 2D. For the foci, we have a distance from the origin or from the center of the ellipse of C, and that's why twice the value of C. That's the distances for the distances between the foci. Now going back here, we have 2D. 2D equals to 2 times 9.238 equals to 18.476. 18.476 units. Okay, that's your answer. For the graphical representation of this problem, this is your figure. Now, since the standard equation has no value for h and k, its center is on the origin. Now, we have a major axis of 16 units, which means the semi-major axis is equals to 8 units. So 8 units from the center of the ellipse to the right and to the left, 8 units. Then for the minor axis, we have a total of 8 units, which means half of that is distance B, or 4 units from the origin upward and downward. For the foci, we have already determined the value of C for the location of the foci, which is 6.928, or this one for the square root of 3 in decimal, 6.928. Okay, this is your C, 6.928 from the origin. For the directrix is 9.238 from the center. Okay, that's your D. So for a total distance of 18.476. So that's how you draw an ellipse. Next problem. An ellipse has the equation 16x squared plus 9y squared plus 32x minus 128 equals to 0. Determine the location of the center, what is the minor and major axis, the eccentricity, length of latus rectum, distance between foci, and the distance between directrices. Now, change first the general equation into the standard form. So we have here 16x squared plus 9y squared plus 32x minus 128 equals to 0. Let's change that to standard form. Now 16x squared, let's move plus 32x beside 16x squared, and 9y squared, we don't have a term with y variable, so this equals to 128. We transpose negative 128 to the right hand side of the equation. So in this term 16x squared plus 32x, we can factor out 16. That's why we have 16x times x squared plus 2x plus 9y squared equals to 128. For this expression to be a perfect square, or a square of a binomial, equivalent of a square of a binomial, we will introduce again additional number, which is equals to divide the coefficient positive 2 by 2, we will have positive 1, and positive 1 raised to 2 is positive 1 also, 1 squared. Then just copy 9y squared equals to 128. Since we introduce here by completing the square positive 1, we should multiply this to 16. So because it is within the grouping of x squared plus 2x. So since we factor out 16, 16 times 1 is 16, shall be added also here on the right hand side of the equation, positive 16. Now rewrite the equation. This will be x plus 1 squared plus 9y squared equals to 144. So the equation should be equals to 1. We divide both sides by 144. Okay, so just distribute the denominator on the first term, x plus 1 squared over 144 plus 9y squared over 144 equals to 1. Okay, 144 and 16, they are both factorable by 16. So 144 divided 16 is 9. This one will be 1. So x plus 1 squared over 9 plus 144 and 9, that's 16. Okay, this will become 16 if you divide both the numerator and denominator by 16, by 9, sorry. Now this is 16 equals to 1. Therefore our standard form of equation is x plus 1 squared over 3 squared plus y squared over 4 squared equals to 1. The location of the center is center for h. For the x coordinate we have -1, and for the y coordinate it's just 0. That's the answer for number 1, or letter A. For letter B, the minor and major axis, that will be based on your A and B. So A should be the one that has a higher value. So A here should be 4 and B is 3, which means that your major axis is along the y axis. For the minor axis is along the x axis. So the axis that has a longer distance is along the y direction for your ellipse. That's why in determining the minor and major axis, the major axis is equals to 2a equals to 2 times 4, that's 8 units. For the minor axis, that is 2b, equals to 2 times 3 equals to 6 units. Now for C, find the eccentricity. For the eccentricity, we have a formula of E equals to C over A, where C is equals to the square root of A squared minus B squared. Now it is equals to 4 squared minus 3 squared. C therefore is equals to the square root of 4 squared 16 minus 9, the square root of 7, or in decimal square root of 7 is equivalent to 2.6457 or 2.646. But if we want to use the exact value, we can use square root of 7 in substituting here in the formula for the eccentricity. Now, A is 4. Eccentricity, square root of 7 over 4 is square root of 7 over 4 equals to 0.661. So, it is less than 1. It is an ellipse. For letter D, the length of the latus rectum. Length of your latus rectum, I just put your the formula here. LR is 2b squared over A, 2 times 3 squared over 4. We have 2 times 9 divided by 4. That is equals to 18 divided by 4. 18 divided by 4 is 9 over 2, 9 halves, or 4.5. Okay? 4.5. That's the length of your latus rectum. Next, letter E. Find the distance between foci. We have already the value of C, which is square root of 7 or 2.646 units. So distance between foci is 2c. 2 times the square root of 7 is 2 to the square root of 7, or 2 to the square root of 7 is 5.292. Okay. So this is 5.292 units. Last question. Find the distance between the directrices. F. So D is equals to A over E. A is 4. Eccentricity is 0.661. Using that, we have 4 over 0.661 equals to 6.051. 6.051 units. So, distance between directrices is 2D. 2 times 6.051 is equals to, I'll just multiply it by 2. The answer, 12.103 units. Okay, now let's show the graphical representation for this problem. Okay, so here's your graphical representation of the equation of the ellipse, wherein our major axis is along the y-axis or along the y direction. So our center determined at question A is -1, 0. So the location of the coordinates of center is right here. If this is your origin, -1, 0 is this point. -1, 0. To locate the foci, this is the distance that you will measure for the distance C that we already determined, which is equivalent to the square root of 7 or 2.646. So going back here, this is 2.646. Okay, so C is equals to 2.646 units. Okay, for the directrix, we need the distance D, which is 6.051. That distance shall be measured from the center of the ellipse, and the distance D is 6.051 units. That's the location of the line for the directrix. And this one is your distance D also, 6.051 units. Now, that's how you solve this problem. Next. Now for the last type of conic section, we have a hyperbola. It is defined as the locus of points that moves such that the difference of its distances from two fixed points called the foci is constant. The constant difference is the length of the transverse axis to A. Now, for the general equation, is ax squared minus uy squared plus dx plus ey plus f equals to 0. So the general equation of hyperbola is somewhat similar to the ellipse, but the only difference is that we have a negative or different signs for terms of x squared and y squared. So they are opposite in sign. Either x squared has a positive sign, but the other is negative, or we have a term for y squared that's a positive and the x squared is negative. So it's one way of identifying that from the general equation it is a hyperbola. Okay, so first take a look at the graphical representation of or an example of a hyperbola. So the hyperbola here is this one, that one. Okay, we have a transverse axis, which is the distances or the distance between the vertices of the hyperbola. This one, v1, v2. Now we have also the conjugate axis, this one. So the sloping line or the slope that we will form there, which is this one with the conjugate and transverse axis. Okay, the slope that we will form there from two different directions can form an x, like intersecting lines here. That's what you call the asymptote. Now our hyperbola will be going to that direction, okay, as it continues, but the asymptote and the hyperbola will never meet. Okay, the asymptote is going the hyperbola is going to the direction of the asymptote, but it will never meet. Next, for the hyperbola with the center at origin, the standard equation or the standard form of the equation of it should be x squared over a squared minus y squared over b squared equals to 1. If the hyperbola with center at origin and transverse axis is on the y-axis, we have an equation of y squared over a squared minus x squared over b squared. Now, as you can observe here, we have the difference with the use of the letter A and B compared to the solution we have on ellipse. On ellipse, we simply use A for the value that has for the denominator of each term that has a greater value. But here, for comparing the standard form here, uh, for the term that has the positive value, or what comes first on the standard form of the equation, so like this one, x squared is the positive one, so there will you put or assign the value for a. Okay, same way, if y squared is the one that is positive when you form a standard form of the equation of the hyperbola, you will assign a on that term, okay, on the denominator of that term. Then that determines the transverse axis. So of course the value for letter B that is assigned there should always be called as the semi-conjugate axis. So that will be used in determining the conjugate axis and the transverse axis. Now, hyperbola with center at any point h and k, just introduce minus h and minus k. Then take their squares. Same here. Elements of hyperbola. If the center is at the origin, h and k is 0, 0, 0. The transverse axis is 2a and the conjugate axis is 2b. Location of foci C. Okay, we also use C again in locating the foci of the hyperbola relative to the center of hyperbola. By the way, the location of the foci, when we go back, sorry, I didn't show it. The foci is right here, okay? It has similarity with the parabola, where the opening is, or where the direction of the opening is, it is inside there, or like that. But the distance C shall be measured from the center of the hyperbola. So here's your center, okay? These are your vertices. So that's why your C is not measured here, but it is measured from the center, right here. Okay, going back. To compute C, is equals to the square root of a squared minus b squared. Sorry, this is plus. This is plus b squared. Okay. Since C is the hypotenuse, that is also the equivalent of the hypotenuse of the triangle formed by the semi-conjugate and semi-transverse axis. We go back again on the figure. C also is equivalent to this distance. Okay, this is C. That's why if we have A and B, this is equals to C. Also, the distance from the foci is equals to C from the center of the hyperbola. So, again, go back. Latus rectum, same formula as of ellipse. So actually, majority of the formula that we can use in determining the latus rectum, eccentricity, okay, it's just the same with the ellipse. Only that C here should be plus. Unlike in the ellipse, we have a squared minus b squared. So take note of that. Okay, your eccentricity should be greater than 1. Then the location of the directrix D, same formula as ellipse. Equation of asymptotes. So your asymptotes there are the slope, or the diagonal line formed by your transverse and semi-transverse and semi-conjugate axis. So to find those equations, or the equation of those lines, we will use y minus k equals to plus or minus m times x minus h. That's similar to the point slope form. of an equation. So m is positive for upward asymptote and m is negative for downward. Okay, doesn't matter since we will use both positive and negative sign for the two equations. So let's solve this example for hyperbola. Conic has the following equation for x squared minus y squared equals to 16. Determine the location of its center. Determine the length of transverse and conjugate axis. Find its eccentricity. Determine the length of latus rectum. Find the distance between foci. Find the distance between the directrices. And what are the equations of its asymptote? That's all. So based on the given equation, it is clearly a hyperbola, since we have a term for x squared which is positive and y squared which is negative. So we will change that to its standard form. So it should be equals to 1. This one should be equals to 1. Therefore, we divide both sides by 16. Okay, we divide both sides by 16. It will become 4x squared over 16 minus y squared over 16 equals to 1. Now, can cancel out 4. What remains is 4 on the denominator. So x squared over 4 minus y squared over 16, or let's change that to the equivalent square, which is 4 squared minus y squared over 4 squared. Sorry, this is 2 squared. 4 is equivalent to 2 squared equals to 1. Now, we have the standard form of the equation. From that, we can derive the center. We can determine the center of the hyperbola. The center is located at the origin or 0, 0, since we don't have a value for for h and k on the derived standard equation. So what's next is to determine the length of transverse and conjugate axis. So that the transverse axis is 2a and the conjugate axis is 2b. So from the standard equation, this is for a. For b, we already determined that a should be the one that has the positive value for the term in the standard equation. So the positive term here is at x. Therefore, we will use 2 as the transverse axis. For the conjugate axis, we have 4 for b. That's why the transverse axis is 2a, which is 2 times 2 equals 4. That's the distance, 4 units. For the conjugate axis, that's 2b equals to 2 times 4, 8 units. C is required to determine the eccentricity. We will use the same formula for the eccentricity equals to c over a, where c here is equals to square root of a squared plus b squared. So c equals to the square root of a is 2 squared plus b 4 squared. C is equals to the square root of 4 plus 16. C equals to the square root of 20. C equals to 4 times 5, square root of 4 times 5. So we have 2 to the square root of 5, or equivalent to 4.472. 4.472 units. So let's just use 2 to the square root of 5 for an exact value for E. So 2 to the square root of 5 over A is 2, cancel out 2, E is equals to the square root of 5, or square root of 5 is equals to 2.236. Okay, 2.236. That is greater than 1. Therefore, it is really a hyperbola. For question in letter D, determine the length of the latus rectum. For the latus rectum, formula is 2b squared over A. So 2 times b 4 squared over A. Yung A is 2. Okay. This equals to 2 times 16 over 2. Cancel out 2. The length of the latus rectum therefore is 16 units. Question E. Find the distance between foci. For question E, distance between foci we have already see here. So let's just multiply it by 2. 2 times 2 to the square root of 5 equals to 4 to the square root of 5. So distance between foci is 4 to the square root of 5, or it's equivalent 4 to the square root of 5. 8.944 units. Letter F. F. Find the distance between the directrices. Let's use the formula again. For D, D is equals to A over E. We have A of 2 and E 2.236. 2.236 units. Divide that. 2 over 2.236. Okay. 0.894 units, or when we multiply it by 2, the distance between directrices, 0.894 is equals to 2 times 0.894, 1.788 units. Okay, last question. What are the equations of its asymptotes? So let's go back here. Letter G. Equation of asymptotes, we have y minus k equals to positive negative m times x minus h. So this m here is the slope of your transverse and conjugate axis. So to determine m, let's just use the formula b over a, or a over b, depending on the location or on what axis is the transverse or the conjugate axis. So let's go back on our lecture with regards to the value of m. If the transverse axis is horizontal, we will use m as b over a. If the transverse axis is vertical, m is a over b. So uh, our transverse axis here is 4 units, and basing on the standard equation, our transverse axis is on the term with the x variable. So which means that our hyperbola is along the x direction. So since our transverse axis, which is 2, is along the x direction, which means that it is horizontal, or our hyperbola is along the horizontal, and our transverse axis is horizontal, we will use b over a. So we have here b over a. B is equals to 4, a is 2. Now m is equals to 2. Substitute now. Since the origin hk is since the location of the center of the hyperbola is at the origin, we don't have a value for h and k. So y is equals to plus or minus m. I will substitute now 2 times x. That's your answer for asymptote, or you can rewrite that equation since this is, we use the equation of a line. Okay, you can rewrite that as positive or negative x plus y, or y plus or minus negative x equals to 0. Since when you transpose, okay, they will just change the sign. Since we have both positive and negative, it will just be the same. So this is correct, this is correct. Next, let's have a graphical representation of this hyperbola. Okay, okay, so here's the figure. Okay, this is the graphical representation of the equation for a hyperbola, which is 4x squared minus y squared equals to 16. So in drawing a hyperbola, you should draw first this box using the semi-conjugate and semi-transverse axis A and B. So A, the distance of 2, should be measured from the center of the hyperbola, or since our center is at 0, 0, this is your origin. Okay, so measure 2 units. Since our transverse axis is along the horizontal, measure 2 units, okay, to the left and to the right. Now that's the location of your vertices, v1 or v2. Then measure the conjugate axis. Conjugate axis is at the y direction. So from the center going upward, this is your distance b. Okay, this is your distance b, 4 units. Downward, 4 units. Or that distance can be translated here. Okay, this is your distance b. This is also distance b. This is distance a, distance a. So you form a rectangle that can be used in drawing your asymptote. Okay, your asymptote is just this diagonal line. Okay, simply that's the slope of, or the inclination of the conjugate and transverse axis. So you just connect the corners and extend it. Okay, from the center to the corner, then extend. That's your asymptotes. Now draw the hyperbola. So from the vertex, you will draw a curve going to the direction of your asymptote, but it will never touch. Don't draw the curve of the hyperbola touching the asymptote. So same way here, draw a curve going to the direction of the asymptote from the vertex. Okay, next, for the location of the foci, it shall be measured from the center. So let's put the location here of your foci. C is 4.472. So from the center of the hyperbola, we will measure 4.472. So this is 1, 2, 3, 4. 4.472 is somewhere here. That's your focus. Another on the left side, on the right side, 1, 2, 3, 4.472 somewhere here. That's your distance C. Okay, this is distance C. There, distance C. Then for the latus rectum, we have a total distance of 16 units. Okay, means that if we measure the distance of a line perpendicular to the focus, okay, to the foci, it should be exactly 16 units. Okay, say for example, sorry, this one. Okay, I just put that there. So okay, so for example, this on the left side we have here. Let's count if it is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, 16 units. So for the directrices, so the location of the directrix should be opposite the opening of your curve or the hyperbola. So it is within the boundaries of this transverse axis. So using this distance 1.788 as the distance between the directrices, we use D as the distance from the center to the directrix. Okay, we shall locate that, and I think it's right over here, 0.894, somewhere here. So the location, let's draw another line for your directrix is right here. Same way on the right side of from the center, 0.894. I think it's somewhere there. That's your directrix. So two lines. We have two lines for directrix for a distance D. Okay, this is distance D. This is distance D. So that's how we draw a hyperbola. Okay. Next problem. Conic has the following equation: 9x squared minus 4y squared minus 36x plus 8y equals to 4. Determine the location of its center, transverse and conjugate axis, eccentricity, latus rectum, foci, distance between foci, the directrices, and equation of its asymptote. So let's solve. Change it first to the standard form. So let's rearrange our equation by grouping the terms with x variable and y variable. So we have 8y equals to 4. So just put the number whole number on the right hand side equation. So let's change this to the standard form by completing the square. So let's factor out first the factorable numbers for each term. We have 9 for this grouping of x. So we have x squared minus 36 divided by 9 is 4x. For this term, for these terms, we can factor out negative 4. If we factor out negative 4 for negative 4y squared and positive 8y, we have positive y squared, but this one would be negative 2y equals to 4. Then, by completing the square, we have 9 quantity of x squared minus 4x. Then we will add a number, negative 4 divided by 2 is negative 2. Negative 2 raised to 2 is positive 4. Minus 4 y squared minus 2y. The number to be added is negative 2 divided by 2 is negative 1. Negative 1 raised to 2 is positive 1. Okay? Equals to 4. Then we will add 4 times 9. 4 times 9 is 36 plus 36. That's the additional value that we will add on the left hand side of the equation, since positive 4 is within the grouping where 9 is factored out for this group. This one we factored out negative 4, so we shall multiply positive 1 to negative 4. Therefore, this is minus 4. Now change this into the square of binomial. We will have x minus 2 raised to 2 minus 4 y minus 1 square equals to 4 plus 36, 40 minus 4, 36 again. Okay, standard form, it shall be equals to 1. So we divide both sides by 36. We will have 9 times x minus 2 square over 36 minus 4 y minus 1 square over 36 equals to 1. So 36 and 9, it's just 4. X minus 2 squared over 4 minus, we have here 9. So y minus 1 squared over 9 equals, then x minus 2 square over 2 square minus y minus 1 square over 3 square equals to 1. For question in A, determine the location of the center. For A, center is at H is with X, so the X coordinate is positive 2. Okay, opposite the sign of negative 2. For the K or the Y coordinates of the center, negative 1, so that's positive 1. Okay, or 2, 1. Simply C is 2 and 1. For B, length of transverse and conjugate axis. Again, in identifying the distance of the semi-transverse and the semi-conjugate axis, A and B, A should always be assigned on the term of the standard equation of a hyperbola where it is positive. So this term is the positive term, therefore your A on the denominator is 2, and B for the semi-conjugate axis is 3. Okay, so the transverse axis is equals to 2a. 2 times 2, 4. Conjugate axis equals to 2b. That's 2 times 3. 6 units. So that's the answers. For C, the eccentricity. Eccentricity of the hyperbola equals to C over A, where C equals to the square root of A squared plus B squared. So C equals to the square root of 2 square plus 3 square. C equals to the square root of 4 plus 9. C is the square root of 13. Substitute now in E. E therefore is the square root of 13 over 2. So decimals 1.803. That is greater than 1, so it's a hyperbola. D, length of latus rectum. Okay, latus rectum is 2b squared over A. Just substitute. B, 3 squared over A, 2. So cancel out 2. The length of latus rectum should be 9 units. That's the answer. For the distance between foci, letter E. Distance between foci, we already have C here. Okay, so that is 2C. So 2 times the square root of 13 is 2 the square root of 13. So the distance between foci is equals to the square root of 13. Okay, 7.211. Okay. 7.211 units. That's the answer. For letter F, okay, just put it here. F is find the distance between directrices. Okay, it's formula based again. That's 2D. But we don't have the value yet for D, which is A over E. A is 2 and E is 1.803. 1.803. D therefore is equals to 2 over 1.803, 1.109. 1.109 units. So 2D is 2 times 1.109. That's the distance between directrices. Okay, so let me just complete that. 2 times 1.109 equals to 2.218. 218 units. Next, equations of its asymptotes. For the equation of its asymptotes, I will just write it here, letter G. So y minus k is equals to positive or negative m x minus h. For the value of m, okay, basing again on the lecture, if it is along the horizontal and based on our on the equation that we formed, okay, the transverse axis is along the horizontal since we have a positive term here for x term. So this b over a. B is 3, a is 2. Substitute now y minus k. Okay, based on the center of the hyperbola. Our k here is positive 1, so just substitute positive 1 equals to positive or negative 3 halves of x minus 2. Okay, now multiply both sides by 2 so that we could eliminate the denominator 2. So this 2y minus 2 equals to positive negative 3 times x minus 2. For positive, okay, for positive, or if it is positive, the equation that will be formed is 2y minus 2 equals to positive 3 times x is positive 3x. Positive 3 times negative 2, negative 6. So we have transpose 3x, they have negative 3x plus 2y minus 2, suppose negative 6, we have positive 6 equals to 0. So negative 3x plus 2y plus 4 equals to 0. That's your equation. Or if you want the term x, or the first term with x variable to be positive, multiply both sides by negative 1. Okay, so that we have an equation of 3x minus 2y minus 4 equals to 0. That's your equation. If it is negative for the slope, 2y minus 2 equals to negative 3 times x, negative 3x. Negative 3 times positive 2, negative 2 is positive 6. So transpose that, we have 3x plus 2y minus 2 minus 6 equals to 0. So 3x plus 2y, okay, they are both negative, so it is negative 8 equals to 0. This is your second equation for the asymptote. So that's your answers. Okay, that's the answers for this particular problem. Again, the graphical representation for this general equation of a hyperbola. Let me just show you. So again, to draw the hyperbola, first draw a box using the transverse, semi-transverse, and semi-conjugate axis A and B. So our center is at 2, 1. So here's your origin. 2, 1. 2 units for the x coordinate and 1 unit to y. So this is your center. Then your transverse axis is horizontal, and we will use that in locating the vertices of the hyperbola. So 2 units to the left, this is your vertex 1. 2 units to the right, vertex 2. So the total distance from this to from the vertex to the center is a. Okay, this is distance a, or it's just the same here. This is distance a. Okay, this is distance a. For the conjugate axis, this is b. Okay, from the vertex to that corner. Okay, it's your distance B. Okay, sorry, this is distance B. Now, after that, after drawing that rectangle, draw the asymptotes. Okay, they are lines. Okay, draw that line intersecting the corners of this rectangle. Okay, from the center going to the corner, from the center going to the corner. So the asymptote will serve as your guide in drawing the curve for the direction of your hyperbola. So from the vertex, draw curve going to the direction of your asymptote, and draw also curve from the vertex on this right side going to the asymptote. Okay, so that's the figure. For the distance or the location of the foci, which is 7.211, that's the distance between foci. But for the distance C, which is equals to square root of 13, or the equivalent of square root of 13 is, when you compute that, it's 3.606 or 3.60555 or 3.606. Okay, that would be here. From the center, we count 1, 2, 3.6. Let's say it's right here. Okay, 3.606, and from the center, 1, 2, 3. Okay, let's say right there. So that's the foci. Then you draw a line perpendicular to that. That's the latus rectum. Okay. You draw a line like that. Okay. That's your latus rectum. And you draw a line here. Okay. That's your latus rectum intersecting the foci. Okay, so just extend that curve. So the distance of latus rectum should be equals to the computed value of 9 units. Now for the directrix, for the directrices, computed that D is 1.109. So measure again from the center of your hyperbola. From the center, 1.109. So here 1.109, 1.1. Say it's right here. Same way here, 1.109 is about that distance. So if I draw another line again from that, okay, we can draw the directrix. Same way, right here, I draw a line there. That's your directrices. So that's how you draw a hyperbola. Okay, let me just label all the parts. This is the directrix. Okay, this is your latus rectum. Okay, that's it. Sorry, asymptotes. Okay, asymptote. This is asymptote. Okay. So that's it, class. That ends our lecture for analytic geometry. So I hope you learned something from this lecture, and take time to read and study the module that I have given. Thank you, and God bless.